Hi, my name is Jeffrey Van Gogh. I'm a tech lead on Android Studio, where I'm responsible for Android's programming language support. I'm excited to tell you about all that's new on Kotlin on Android. For those of you who are new to Kotlin, it's an expressive, statically typed language, perfect for writing apps on Android. It's mature, open source, and it's used by millions of developers around the world. A lot is happening around Kotlin for Android, so let's start by looking at Kotlin's momentum. It's been 4 years since we officially announced support for Kotlin on Android, and its use continues to grow. Looking at the top 1,000 apps by number of installs on Google Play, we see that 80% of them contain Kotlin code. And 60% of Android developers are now using Kotlin. And it's not just the top of the market that is adopting Kotlin. Several 100,000 developers completed our Android Kotlin training courses and code labs in the last year. We also launched Android Basics in Kotlin, a full course in learning writing Android apps for beginners. Of course, Google has started using Kotlin in our own apps too. It is currently used in over 70 of our published applications. We have adopted coroutines as the future for concurrency across both Android and server applications written in Kotlin. As a result, the amount of Kotlin code in Google's monorepo is rapidly growing. We now have over 100 teams and several thousand engineers using Kotlin across Android and server applications. Kotlin is powering the servers for some of our biggest products, including Google Voice, Nest, and Google Shopping. These are impressive adoption numbers, and we always knew that there are many reasons why so many people love Kotlin. You've heard us talk repeatedly about Kotlin's expressiveness, with features like properties and extension methods, the safety it brings through things like nullability and string templates, easy interoperability with existing code, and structured concurrency through coroutines. These are benefits that we have experienced ourselves and hear users talk about. The cool thing is that we can actually measure some of these benefits. A recent Google internal analysis of apps available on Google Play showed that apps that adopt Kotlin saw over 10% reduction in the number of users who experience crashes. Even with all these benefits, we do understand that learning any new language can be a challenge. To help with this, we launched the Kotlin Google Developer Experts program. We have 50 GDEs all around the world who share their knowledge about Kotlin in talks, articles, and through open source contributions. So follow them to learn more. These GDEs provide Kotlin-related content for Android, server, and multi-platform. Alongside all these great educational resources, we're also working on making Kotlin easier to use through ever-improving tooling. First of all, you can now write your Gradle build files in Kotlin script. This eliminates the need for you to learn Groovy and at the same time gives you all the benefits of Kotlin in your build files, like autocomplete, refactoring, and more. This was enabled by a brand new Kotlin DSL for the Android Gradle plugin. We recently posted documentation for this new DSL on developers.android.com. Talking about Kotlin Gradle, we made several improvements in Gradle's interaction with Kotlin. We made CAP more reliable and incremental. We also fixed several issues in incremental Kotlin compilation, and we landed Gradle configuration caching in Kotlin. Together, these should give quite a bit of build speed improvements. Another thing that will help build times, as well as improve expressiveness, is Kotlin Symbol Processors, or KSP. We launched the first developer preview of KSP a year ago, and recently the first alpha. The goal of KSP is to make symbol processing a first-class feature in the Kotlin ecosystem. No more Java stub generation via capt and associated long build times. KSP integrates with the Kotlin compiler, and it provides access to all Kotlin symbols. It has support for incremental and multi-run processing, and it is multi-platform ready. The Jetpack Room library has KSP support in beta, and we're seeing 2 times faster processing with KSP than we saw through capt. We need your help in converting existing annotation processors to KSP. You can find the status of KSP and a list of popular processors via the link on the slide. All these improvements will hopefully make your builds faster, but you care about IDE performance too. Our team has been working closely with JetBrains to address performance issues in the IDE. In Kotlin 1.5, we fixed several performance issues that affect large, real-world projects. As a result of these improvements, we're seeing up to 20 times faster auto-import suggestions and up to 2 times faster code completions for projects with complex dependency graphs. Make sure to upgrade to the latest versions of Android Studio and the Kotlin IDE plugin to benefit from these improvements. Even with all these efforts, we know that both build speed and IDE responsiveness remain the top concerns with adopting Kotlin. To address this, Google and JetBrains have been working on a rewrite of the compiler. Here you can see a typical Kotlin compilation pipeline. The compiler is divided into 2 parts, the front-end and back-end. The front-end takes care of code correctness, and the back-end is responsible for code generation. We started a rewrite with the new JVM IR backend compiler, which was launched in Kotlin 1.5. The new IR backend compiler comes with a rich set of compiler plugin APIs. These APIs are what powers the Jetpack Compose language extensions. The new backend also allows us to unify the front-end of the compiler between JVM, JS, and native. Both JetBrains and Google are working hard on bringing you this new unified front-end and hope to have it available later this year. The new frontend will bring 2 times faster compilations and drastically improved IDE performance. Please give both the new backend as well as the experimental frontend a try and send us feedback. Even with amazing tooling, a language would not be complete without a great set of libraries. So I'm going to hand it over to Wojtek to talk about some of the improvements we've made in that area this year.
Thanks, Jeffrey. When we first announced Kotlin support on Android, we started something called Android KTX. Back then, it was a single library with some useful Kotlin extensions for framework APIs. Today, KTX has grown into dozens of artifacts for various Jetpack APIs. Moreover, true to our Kotlin first commitment, we started writing new libraries in Kotlin. That way, we can benefit from features like coroutines and flow in popular libraries such as paging and data store, while keeping their APIs usable from code written in the Java programming language. And then we went even further when we decided to fully invest in Kotlin when building our next generation UI toolkit, Compose, which is based around the Kotlin compiler plugin, and as such needs the code to be written in Kotlin as well. Other product teams at Google are finding success with Kotlin too. With releases of extensions for SDKs such as Maps, Places, Firebase, and Playcore, writing apps for Android becomes safer and more seamless for Kotlin developers. Looking beyond Android, there are already libraries built by server-side engineering teams at Google, such as the Kotlin gRPC library, which we open-sourced last year. And just recently, the new Kotlin bindings for protocol buffers were released, offering a Kotlin DSL for working with protobufs. Last year, we announced that Kotlin coroutines are the officially recommended way to do asynchronous operations in Android when using Kotlin. Many of the libraries that I just mentioned incorporate coroutines in their API surface, including flows for observable streams of values. With new additions of stateflow and sharedflow to the coroutines library, we'll be looking at how to best incorporate them into our training materials and future APIs. For example, developers ask us if live data will be deprecated in favor of stateflow. So far, live data was a convenient way to observe state updates from the UI, and it remains exactly that for Java programming language users. In Kotlin, stateflow can serve an equivalent function, while also supporting the power of suspending functions in operators. And if you had to keep using live data just because of data binding, you'll be happy to hear that the newest versions of Android Studio support observing state flows directly in your bindings. For observing flows in the UI without data binding, you could use the Android X Lifecycle KTX library. However, the existing functions, such as launch when started, have a particular pausing behavior that could potentially lead to wasting resources when the UI is not active. We are currently adding a new set of functions that will make it safe to observe any flow in the UI, thanks to automatic cancellation and restarting of any jobs scheduled using this API. So watch out for alpha releases of Lifecycle KTX and give us your feedback on these new APIs. Because coroutines are becoming more common in apps, the ability to properly debug and understand what's going on under the hood is very important for developers. That's why we're finally bringing the coroutines debugger from IntelliJ IDEA to Android. It will be available using a future version of Android Studio, but let me quickly show you what it can do. When using the debugger, you'll be able to switch to the Coroutines tab, where you can see details about active dispatchers and any coroutines. You can check the coroutine status, such as running or paused in the UI, or dump everything into a file. And lastly, one reminder. Together with JetBrains, we are phasing out the support for the Kotlin Android Extensions plugin, specifically when using Kotlin synthetics for Android views. The recommended migration path is to use Android view binding. The Parcelize feature is still supported, but it has now moved to a separate plugin, Kotlin Parcelize, so all you need is to update your build files and imports. Now, we've talked about Kotlin today, but we didn't forget about developers who are not using Kotlin in their apps. In fact, all of the Android platform APIs are written in the Java programming language and are used by Kotlin and Java developers alike. And there are also many popular libraries that are written in Java, which are contributing to a healthy developer ecosystem. Kotlin's popularity and success comes in a big part from being able to evolve quickly and add modern features that developers want. However, the Java language spec does not stand still. And today, we can see many similar improvements being incorporated into it. For example, records, which resemble Kotlin data classes. We will be assessing these new features and working hard to bring them to Android development. We have two important projects that are helping us achieve this goal. First, we're bringing support for additional language features in Android Gradle plugin 7. We're also adding new Java language APIs to Android 12, and we're making them available for use on older devices through library desugaring. And finally, I'm excited to share that the Android runtime, known as Art, is becoming an updatable mainline module starting in Android 12, which means that we'll be able to update supported language features and even add new APIs on future Android devices directly, without waiting for full operating system updates. For now, there is no action required from developers. We will share more details about how this affects SDK targeting in your apps in a future announcement. We hope you like what we have in store for Kotlin and Java language development on Android. Whether you're looking to onboard developers to Kotlin, or if you're a library author looking to use new language features, we got you covered. Check out the links in the description below for more information, and look out for more content on coroutines, Flow, KSP, and more coming to our social channels soon. Thanks for watching, and go build better apps with Kotlin.